I'm not going to do a presentation on a type of integral. I guess if you have this in your toolkit and actually you have it beyond kind of the exam on this type of integral, and you actually keep it and you retain it, then you, I think, will become an integration jock. But anyway, let me show you what I'm talking about. So let's just remember what the product rule of differentiation was. So let's say I had two functions. Let's say f of x times g of x. F of x times g of x. And I wanted to take the derivative of this. So I take the derivative of f of x times g of x. Well, the chain rule just told us that this is just the same thing as, let's say, the derivative of the first function, f prime of x, times the second function, g of x, plus, now the first function, f of x, times the derivative of the second function. And I'll show you where I'm going with this in a second. Now, if we were to integrate both sides of this equation, right? Because, I mean, we're still doing algebra on some levels. Anything you do to one side of the equation, you have to do to the other. So if we were to integrate both sides, well, if you integrate this side, you're taking the integral of a derivative. You just get back to what you took the derivative originally of. So this just becomes f of x times g of x. And then we have to integrate the right-hand side. Well, that just becomes, and we're doing the indefinite integral, kind of the antiderivative, but we can use this tool when we do definite integrals as well. So that's the integral of f prime of x, g of x, dx, plus the integral of f of x, g prime of x, d of x. And now, this might seem a little bit arbitrary, and it is a little bit arbitrary. Let me take, well, I could take either of these, but let me just take, I don't know, let me take this one and move it to this side of the equation. So I'm going to subtract this term from both sides of this equation. And so we could say this, so let me change colors because this could get confusing. This term right here, we could say that term, f of x, g prime of x, d of x, is equal to this term, let me switch back to the yellow, is equal to f of x, g of x, minus this term. Let me do this. Right? Because I put it onto this side of the equation. So minus this term. Minus f prime of x, g of x. So what did I just do? It looks like I am just essentially playing with the product rule from differentiation. That's all I did. And you're probably wondering, well, Sal, this is all nice and it looks fancy, but what good is this going to do me? Well, what I essentially just did is I kind of proved this. You could call this a formula, but I often forget it, especially once I haven't done it in a long time, and then I actually just reprove it to myself just by remembering the product rule. But this is called integration by parts, and I'll show you where this is useful. Let's say we want to take the indefinite integral of, I don't know, x cosine of x, d of x. Well, everything we have in our integration toolkit so far, I don't think helps us here, right? Because we don't have a function and its derivative, so we can't do, substitution or which is the same thing as the reverse chain rule. This isn't a simple polynomial. So if you kind of encounter this when you're doing integrals, kind of the last toolkit, and this is pretty sophisticated, is to do integration by parts. And so how can we use this for integration by parts? Well, integration by parts tells us that if we have an integral where we have a function and then the derivative of another function, then we could use this formula to hopefully simplify it. So what I'm going to do, and you might view this as, well, Sal, how did you know to do this? And I'll tell you my thought process actually after I show you what I did. We always, in math in general, you always want to simplify. You always want to move from something that's complicated to something that's simpler. So in this situation, if we could assume that x is f of x, and we could assume that g prime of x is cosine of x, or we could assume the other way around. The reason why I'm going to assume that x is f of x, and I'm going to assume g prime of x is cosine of x, is because later we want to take the derivative of f of x. And the derivative of f of x simplifies things a lot. And we also want to take the integral of g prime of x, right? Or we want to take the antiderivative of g prime of x. And the antiderivative of cosine of x is sine of x, which is just as complicated. It's not making it any more complicated. And actually, try it the other way around, and you'll see that if you took the antiderivative of x, you get something that's more complicated. You get x squared over 2. So that's the intuition, and let me just solve through it, and hopefully it'll make a little bit more sense. So if I assume that f of x is x, and g prime of x is cosine of x, then f of x, right, this yellow term, let me write it in yellow just for fun. So f of x, so I'm saying that f of x is x, right? F of x is x, so that's x. And let's say g of x is cosine of x, right? I'm sorry, g prime of x is cosine of x. So the derivative of g of x is cosine of x. So what's g of x? Well, it's the antiderivative of cosine of x. So that's sine of x. I hope you understand what I'm saying. This can be a little confusing. Let me write it separately here. Actually, well, I'm running out of space, but I'll write in the corner right down here. See, I'm saying that f of x is x, and I'm saying that g of x is sine of x. Right? And the reason why I knew g of x is sine of x is because I said the derivative, I said g prime of x is cosine of x. Right? So if the functions, if the derivative of a function is cosine, then we know the function itself is sine, right? That's just something you memorize. And I haven't proven it to you yet, but it's usually in the inside cover of your calculus book. But let's just move forward. And then this is minus the integral of the derivative of f of x. Well, what's the derivative of f of x? Well, we said f of x is x, right? So the derivative is just 1 times g of x. Well, I already said that g of x is sine of x. Sine of x. And I think you would agree that we've now simplified this a good bit, because this is just the integral of sine of x, right? So this is just equal to x sine of x, right? This is just this first term right here, minus, and what's the integral of sine of x? Well, the derivative of, well, let me make it even simpler. Well, we can make this a minus, right? We can make this a minus sine of x and make this a plus, right? And now it's really easy. What's the antiderivative of minus sine of x? We can ignore this 1. What's the antiderivative of minus sine of x? Well, yeah, it's just cosine of x. And we should never forget the plus c. So we just used the product rule to derive this formula for integration by parts. And in a lot of calculus books, they do this, u and v and dv, du. This is the same exact thing. I like this more because it naturally makes more sense to me. It's easier for me to read, and I can derive it any time just from the product rule. So I don't have to necessarily memorize it. You might want to memorize it for the exam because it's faster, or when you take the AP exam. But when you do calculus, I don't know, it's been about 15 years since I learned it, and I just remember, well, integration by parts is just really a derivation of the product rule, and that gets me back to the formula. I don't even have to look it up, and then I can use it. So that's an introduction to the integration by parts. In the next presentation, I will do a bunch of examples, well, as many as I can fit into 10 minutes, of actually using integration by parts to solve fairly fancy integrals. I'll see you in the next presentation.